Okay, so here we are again. Okay, so looking at number 9. Find the percentile for the data value. So we go to our final exam notes to look for it, and it looks like it's on number 2 here. If I can get there. Yeah, so number 2, find the percentile of a data value. So looking at number 2, what do we actually do? Remember that percentile means percent to the left. Remember that that's what percentile actually means? If they tell you that you have a new baby, and your baby, they tell you the height of your new baby boy is at the 17 percentile. 17. Let me write it here. Your height of your new baby boy is at the 17 percentile. Remember what that means? Percentile is like a ranking system which starts at 0 and goes all the way to 100, huh? That's what percentile is. It's just ranking from 0 to 100. And so, 50 is right in the middle, 50 percentile. If your baby was at the 50 percentile, that'd mean totally average height. So if your baby boy's at the 17 percentile, that'd be about right here. About 17% along the way compared to all other newborn baby boys. So, all right, so that's the idea of percentile. It's just a ranking from 0 to 100. So it basically means percentage to the left, right? If you're here at the 17 percentile, that means left of you is the bottom 17% of baby boys, and above you is whatever, 83% of all newborn baby boys. That making sense? Percentile is percentage to the left. It's the percentage that is below you. It's your ranking. So what do? So find the values in the list, count how many values are to the left of that value, then divide this number by the total amount. All right, let's go back and do it. Here we are. So for this data value 6, there's the 6 right there. So how many values to the left? 1, 2, 3, 4, 5, 6, 7. 7 values to the left. So there's 7 values smaller than the 6, aren't there? In that list. See how they're listed from smallest to biggest. So there's 7 values that are smaller. So basically we're trying to figure out what percentage of the way along is that 6. How far along, what percentage is he? What percentage along the way is he? His percent is 7 out of what total? Oh, 20. It says right there, 20 numbers. 7 out of 20. Divide that in your calculator. 0.35. There it is. That's 35 percentile. That means that number, that value of 6 is 35% along the way of those numbers. He comes after 7 numbers, 7 out of 20. You see, that's what part he comes after. He comes after 7/20ths of the list. So that's his percentile ranking. He's 35% along the way. Look, he looks like about 1/3 of the way, doesn't he? 35% is about 1/3. That makes sense? We'll go on to number 10. A student earned BBACD. These courses had these corresponding credit hours, units, 45154. The grading system, as you know, is A is 4, B is 3, C is 2, D is 1, F is 0. Compute the GPA. So how do we find the GPA? Where do we see that on the final exam notes? That's number 1, isn't it? Yeah. Back here. Calculate GPA. There it is. Calculate GPA. And so what do they say you're supposed to do? Oh, I'm showing you a by-hand method there. Oh, yeah, don't do that. Don't do that. You could do that, but it's easier. Instead, just put down L. Here's an easier way. I didn't realize I had the old by-hand method there. Just put in L1 the grades, yeah. Put in L1 the grade points. Meaning A is 4, B is 3, etc. And then put in L2 the units. Yeah, that'll do it. Just put in L1 the grade points, This will be easier than once you want to make a change there to your final exam notes. I need to update that. L1 is the grade points. L2 is the units. And then when you're all done, perhaps I didn't put it there. So basically what you do is you put, like I said, you put L1 the grade points, L2 the units, and then at the very end, you go, change color, you go second, or you go, where do you go? Stat, yeah, stat, and then calc. So then you hit stat, and go over to calc, hit enter, and then when one var pops up, here's the new part. When one var pops on the screen, you got to have both these. So you got to go L1, comma L2. You need both. You need both the grades and the units. L1, comma L2. Hit enter and find the X bar, which will be 2.37. 2.368, blah, 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 blah. Rounds to 2.37. Are you getting that? Well, I'll go back to the numbers here. So let me help you with it. So if the grades are B, I gotta have a little more room. I'm gonna move it over here. So the grades are B, B, A, C, D. Remember how the grade points work? How much is a B worth? 3.0. That's a 3, the A is 4, the C is 2, the D is 1. That's what you put in L1. Those numbers, the grade value numbers. And then in L2, you're going to put the units. So L1 is the grades. L2 is these. What are the units? It's these over here. The credit hours. 4, that was a 4 unit, and a 5 unit, and a 1 unit, and a 5 unit, and a 4 unit. Put those in L2, the units. So in L1, you put the grade values. In L2, you put the units. And then you hit stat. Go over to calc, hit enter. When it says 1 var, you put L1, comma L2, hit enter, and you'll get the answer 2.37, 2.368, whatever. That good? On some of the newer kind of the newer TIs, they show list and frequency list, don't they? And then you just put L1 and L2 that way. You don't do a comma. Mine's the older kind where you got to do the comma. So there's two kinds out there. So if yours says list and frequency list, put L1 and L2 in those two blanks. We good? That coming out? Getting 2.368, whatever. So you can calculate your GPA. All right, I'm going to move on. So number 11. The weekly salaries in dollars of 24 randomly selected employees of a company are shown below. Construct a box plot for the data set. So how do we do that? You'd put all this data in L1, and then, so just put all those numbers in L1, and then when you're done, just hit stat, go over to calc, hit enter, and when it says 1 var, just put in L1 and hit enter. Or if you have the newer kind of calculator that says list and frequency list, you just put in L1 and leave the other part blank and hit enter. And then it'll show you the 5 numbers. You're basically looking for those 5 numbers. So you should get, it's B, so you should get these 5 numbers. 310, 510, 705, 1225, and 3700. Are you getting those numbers to show up? And they're under min. I think they come under min and Q1 and median and Q3 and max. So you'll get a min of 310, Q1 of 510, a median of 705, a Q3 of 1225, and a 3700 maximum. That coming out okay? So that's what you should get. When you put all the data in L1 and do second stat calc enter, list is L1, leave the frequency list blank, or just one var L1, enter on the older kind. So it'll do a little box. It's just telling you the 5 numbers for the box plot, and you have them that way. All right, on we go to number 12. Recall the Boy Scouts example. That was like the first day of class almost. Remember the Boy Scouts example? Among the 50 states, if we take those states that have more Boy Scouts, we find that 20 years later, those same states have more criminals. So the Boy Scouts organization must be producing criminals over time. Of course, that's not true. What was the point of the example? Let's go through it. Is it A, convenient sampling is not a reliable sampling method? Was that the point of that example? No. What's the answer? The correlation does not imply causation. Remember that? Just because two things are connected doesn't mean one's causing the other. That was an important point we learned. Right? As you take in data, remember that. That's almost the most important point in the class. Some people call that one of the number one discoveries of statistics in the last 100 years, is that two things can be connected without being in a causation relationship. All right, number 13. So the test scores of 30 students are listed below. Find P46. So that's the 46th percentile. In other words, they want us to find the number in that list that's 46% of the way along. Does that make sense? In other words, it's almost halfway. You get the idea? It's this percentile ranking thing again. Right? Here's the lowest number in the list, 32, and just goes up, 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 up. Keeps going higher, higher, all the way to 99, which is the highest number in the whole list. So it wants us to go through that list and find what number is 46% of the way along. No, it's just before half. Right? 46% is just less than 50%. So find the number that's 46th percentile. Remember, percentiles are ranking from 0 to 100. So which data value is just below halfway? Well, let's go to our final exam notes. What number is it? 3. We haven't got far, have we? For all of our work. We're only on number 3. Find the P40, etc. How do you do it? Well, you start with P times N. If that's a whole number, you do one thing. If it's a decimal, you do another. Okay, let's go back and find P times N. So, P, that's the P is the 0.46 times the N, that's the P times the N. What's the N? 32, right? So if we multiply those, 0.46, we get 14.72. What do the notes say we're supposed to do if we get a decimal? We got a decimal, huh? You're supposed to round up. Yeah. So round up. So that'll become 15. So is our answer 15?
No.
It's the, what is it then? 15th number. We've got to go find the 15th number. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. There it is. 15th number is 68. There it is. So 68 is just under halfway through that list. It looks right, doesn't it? 46th percentile. Making good sense? So make sure you can do that, whatever it says on that notes there. If it had become a whole, what if I would have got a whole number instead of a decimal? What does it say you do if you get a whole number? You take the number in that spot and the next number, add and divide by 2. Remember those? I better move on. We got a lot of questions, so I'll move on. Number 14. The systolic blood pressure of 18-year-old women is normally distributed with a mean of 120, whatever those are, millimeters of mercury. and a standard deviation of 12 millimeters of mercury, what percentage of 18-year-old women have a systolic blood pressure between 96 and 144? What kind of question is this one? Where are we going to find this on the final exam notes? So feel free right now to add anything you want. I hope you're adding to those final exam notes whatever is helpful for you. So going back here, what's going to key us in? Oh, there was the Boxplot one. We already did that. It doesn't look like number 5. 6, it's not gambling and insurance. Which one is it?
It's not on there. It's not on the final one. It's just on exam
It's
1.
not on there. Hypothesis test, confidence intervals. Okay, yeah, so it's number 8. So go to the final exam notes and find number 8. So final exam notes, number 8. And how do we know it's number 8? Because it says normally distributed. That's the key word. So grab that normally distributed word. And what does it say there that we do? Yeah, draw a bell curve. You don't have to, but it would be helpful. So remember how we used to draw these bell curves? And you put on there the middle. What's the middle? Yeah, the mean. The mean's the middle. The mean is 120. So the mean's 120. And then put on there what they're asking for. What are they wanting us to figure out? Between 96 and 144. So here's 96. Here's 144. They want us to find that area between 96 and 144. Right? I knew 96 was smaller than 120, so I put it to the left. Right? This is like a number line. And 144 is bigger, so I put it to the right. So they want me to find that shaded area between 96 and 144. So on that number 8, doesn't it give you 3 options and say something like, is it asking for a percentage or giving you a percentage? Right? That's the big distinction, right? Isn't that what's underlined on number 8? Is it asking for a percentage? So on this question then, are they asking for a percentage or giving us a percentage? Look, do they ever give us a percentage? No. There's no percentage given anywhere in this question. So they must be asking us for a percentage, huh? They're asking for percentage. And what percentage? They want to know the percentage of that shaded region. They're saying what percentage of the whole taco there, of the whole bell curve, what percentage of that whole thing is shaded? That's what they're asking. What percentage of the whole curve is shaded? How do we figure that out? What does it say on the notes? Normal CDF, which is left edge, right edge, mean, and standard. Remember this is all coming back to you? Way back? It's been a while, hasn't it? So we do normal CDF. Find that on your calculator. And that's under distributions? Mm-hmm. Yeah, you got it. So it's not under stats and tests where we've been going for the last 2 months, month and a half at least. You got to go to distributions, which is above the vars key, second vars, distribution, normal CDF. And what's the left edge of the left edge and right edge always mean the left edge and right edge of the chunk of shading, huh? So this is the left edge, and this is the right edge of the chunk of shading. 96 is the left edge. 144 is the right edge. The mean is 120. Standard, they told me, is 12. Hit the buttons on your calculator. What do you get? 0.95. So there it is. 95%. We good there? Number 15. If the standard deviation for a set of data is 0, which of the following must be true? So this is kind of like they say, this is a gut check. This is a check on your feel of standard deviation. In other words, we have there's nothing to calculate. There's nothing to put into our calculator, nothing to add, subtract, multiply, or divide. It's just, do you feel standard? If you feel standard deviation, this question is child's play. If you don't feel standard deviation, this question is hard. So let's remind ourselves what standard deviation really is. So this is actually, I think, for your lives, more important than all these calculating things. Because in real life, you will read things, for sure. You will read things that mention standard deviation. So if they say blah, 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 the standard, what if I say on the final exam, or the last exam we just took exam for, the standard deviation was 10. What if I was to tell you that? What does that even mean? Standard deviation is 10. So I don't mean like how's it calculated. I just mean what is that? What is the feel of that?
Far it deviates from the mean.
Yeah, exactly. Standard means average, like typical, and deviation means distance from the middle, from the mean. Exactly. That's what standard deviation means. That means how spread out the data is. Like how far are people from the middle? Right? You could have people take an exam and a bunch of people get 95 and 90 and 99, and then a bunch of other people get 20 and 23 and 29, and you could have an average of 70. That would be a data with that would be a standard deviation that's huge, that's like 50 or something. Average distance from the middle, maybe be like 40, or it might be like 35. So that'd be 35. Let me just give you some examples here. That would be a data set. Now, or you could give 6 people a test, and the average is still 70, and they all got right around the 70. They got like 68, 69, 71, 72, 75, 65. So those people got all around 70. Both these tests, notice, have the exact same middle, don't they? Both these tests have the same average of 70. These 6 people that took this test, a whopping high standard deviation. These 6 people are all really close. Their standard deviation is probably only like 2 or 1.8 or something. Do you see what standard deviation is? It's a measure of the spread, isn't it? It's a measure of how far the numbers are from the middle, typically. Right? In the first data set, the numbers are really far, but people either aced the exam, got an A, or totally bombed it with a really bad F. Right? The average is still 70. Whereas down here, they all did pretty average. Nobody aced it, nobody bombed it. They all did pretty average. In fact, they're all real tight together, aren't they? So they have very little deviation from each other. The standard deviation, the average amount of deviation is very low. So that's what standard deviation is. Average distance from the middle. So, okay. So what does it mean then if standard deviation is 0? What does that mean about a bunch of numbers if they deviate from one another by nothing? All the same number. They're all identical. There's no deviation, huh? They don't deviate from each other at all. Does that make sense? For standard deviation? Good. All right, so I'm going to move on. 16 is a good one. Yeah. 16. Now, remember this problem? It's been a while. Elementary school class ran 1 mile in an average of 11 minutes with a standard deviation of 3 minutes. Rachel, a student in the class, ran 1 mile in 8 minutes. And then you got the junior high and the high school, and then you're supposed to rank the runners in order from fastest to slowest relative to their classes. How do you do that? Do you get the idea first off? Do you get the feel of what they're talking about? How did Rachel do in her class? Rachel, let's see. Rachel ran the mile in 8 minutes. The average in her class is 11 minutes. So she's pretty fast. She's better than average. Kinji is a junior high student, and that person ran the mile in 8.5 minutes. The average in Kinji's junior high class is 9 minutes. So Kinji's a little faster than average, but not very much, huh? Only a little bit. And then the high school student, Nita, is that Nita? Nita ran it in 8 minutes, And her class has an average, her high school class has an average of 7 minutes. How did Nida do? She's slower than average, isn't she? Even though she's getting the same time as the elementary student Rachel, she's slower than average compared to other high school students. So the whole point here is, how do we compare values in totally different systems, right? Rachel's running against other elementary school kids where the average is pretty high. And then Kenji's running with other junior hires, and Neda is running with other high school students. How do you compare numbers in totally different data sets to say which one did better in their groups? But remember the thing that does that for us? You see it on the final exam notes? You compare different groups with, anybody? Last call? Nobody? I know it's been a while. Z-score. Z-score. You've got to calculate the Z-score for each of them. That's what a Z-score is. It tells you how you're doing compared to the other people in your group. It specifically tells you how many standard deviations you are above or below the middle in your group. So we calculate the Z-score for each of them. So then for Rachel's group, the Z-score, I'll put the formula down here. The Z-score is your score minus the mean over the standard deviation. So it's score minus mean over standard deviation. So we're going to do it 3 times. So for Rachel, what was Rachel's score? Her time, 8 minutes. Minus the mean, which is 11 minutes, over the standard deviation, which is 3. That'll come out -1. There's Rachel's standard deviation. There's Rachel's Z-score, -1, meaning she is exactly 1 standard amount below the average. She's faster than average by 1 standard amount. How about Kenji? Kenji's time, 8.5 minus the mean of 9 over the standard deviation of 2. I think you get minus 0.25. Am I doing that right? All right. Okay. And then, so that means Kenji is faster than average. She's below the average time, but only by 1/4 of a standard amount. She's not that much below the average. And then finally, we've got Neda. And Neda's Z-score, her time, 8 minutes minus the average of 7 minutes over the standard deviation of 4 minutes, is positive 0.25, meaning she's above average. Her time is slower, higher than average by 0.25, meaning 1/4 of a standard deviation. So we're supposed to rank the runners from fastest to slowest. So who's the fastest compared to their group? Yeah, Rachel. So Rachel is fastest. Rachel's fastest. Next comes Kenji. And then last comes Neda. So whatever answer that is. Rachel, Kenji, Neda. C it is. That good? Remember that Z-score stuff? All right, on we go to number 17. So all that positive, negative test probability of a false positive. So try that one. All right, so their question on number 17 is probability of a false positive. So whenever they say probability, let's first think about that word. We'll get to the false positive thing in a minute. When they say to us probability, Do you realize what goes on the bottom of every probability question? Total. Yeah, do you remember that? Probability is always the number you're looking for over the total. Yeah, the bottom of probability is always total. Why? Well, just think about like if I was to roll a die, right? What's the chance of getting a 6? It's 1 in 6 because there's 6 different things that can happen. See how the bottom is always the total number? If you flip a coin, what's the chance of getting heads? 1 out of 2. If you're among 10 people and they're going to have a drawing for some kind of prize, what's the chance you're going to win? 1 out of 10 because there's 10 total, huh? So in probability, the denominator is always the total, isn't it? So, okay. So the denominator is going to be the total. What's the total number of, like if you add all these up? 435?
Yeah.
Okay, thank you. So the total of all those, that's going to be the denominator. There's 435 total subjects, in that little test situation. So now what's the chance if you grab one of those 435 people at random, what's the chance that you're going to get somebody that happened to get a false positive test result? Which group there among the 4 groups is the false positive? Maybe we should walk through it for a minute. Tell me about these 87. Let's just start with the 87. Tell me about those 87 people. What do we know about those 87 people? Yeah, they tested positive and they have the disease. Right? Tell me about these 27 people. They tested positive, but they really don't have the disease. What's that called? False positive. That's our group, huh? That's our false positive group. That's the numerator. 27 divided by 435. So we just do that on our calculator. And we get, I'm getting 0.062. There it is. 0.062. Is that good? Questions on that one? All right, on we go to number 17. Oh, is that the one we just did? We just did that one. All right, on to number 18. Sample of 100 wood, 100 graphite, tennis racket, and 100 graphite tennis rackets are taken from a warehouse. Among these, 12 wood and 17 graphite are defective. If one racket is randomly selected from the whole group, find the probability that the racket is wood or defective. Hint, construct a table. Remember these make your own table? Those are important. For sure there'll be one of those on the actual final where you got to make a little table. So let me let you do that. Okay, so we make this table. We're going to make it, you could put wood and graphite on the top or the side. It doesn't really matter. Maybe I'll just put it on the top. The side. Wood and graphite. And then what's the other? So you're going to put one of the characteristics on the side, wood and graphite. The other one on the top. What's the other characteristic we're talking about? Good or defective, huh? If a racket is good or if it's defective. Yeah. And again, you could do it. I'm putting wood and graphite on the side, but you could put them on the top. It's totally good. So, all right, so there's 100 wood rackets. So that's the total, isn't it? There's 100 total wood rackets and 100 total graphite rackets. 12 of these, 12 of the wood are defective. So 12 wood are defective and 17 graphite are defective. And so then you just subtract, huh? And you get 88 and what's this, 83. All right, good. So we know the layout. And now what's their question? You're going to grab one racket at random. What's the probability? What's the probability that it's wood? And let me bring it up here. What's the probability that it's wood or defective? Let me give you. Okay, so I'm just going to go among them and say which ones are wood or defective. Well, both of these are wood, and this group is defective. Huh. So we just add all those up, and that's going to be 117, isn't it? over 200. Remember, the bottom is always total on probability. So it's 117 of the rackets are either wood rackets or they're defective, right? Because there's 100 wood rackets, and then there's 17 other rackets that aren't wood, they're graphite, and they're defective. So there's 117 out of 200. Divide that on your calculator. I'm betting you're going to get that. Well, they're close. I don't know. 0.585?
Yes.
All right. 585. There it is. Is that good? I'll try number 19. 66% of the adults have health insurance in one town. What's the probability that 4 adults selected at random from the town all have health insurance? Yeah, do you see this is binomial? How do you recognize binomial? Yeah, they either have the health insurance or they don't. 2 possibilities, right? You've either got the health insurance or you don't, binomial. And also there's no mention anywhere. It doesn't say normally distributed is not stated. See how it never says blah, blah, blah is normally distributed? So it's not one of those. It's not one of the normal distribution, draw the curve things, because it never says anything is normally distributed. So that's how we hone in on binomial. Now, what does it say we do in the binomial thing? We're saying, what's the probability that all 4? So that's the probability that exactly 4, right? All 4 means exactly 4, doesn't it? Right? We're selecting 4 adults. We're going into this town and at random we're talking to 4 adults and we want exactly 4, all 4, to say, yes, I have the health insurance. What's the chance we're going to get all 4 to do that? So the probability of exactly 4. So what is that? Binom PDF. Yeah, binom PDF. This is under second distributions, right? VARs, distributions again. Binom PDF. And binom PDF, how does it go? What are the things we put in there for binom PDF? Number of trials. And probability. And what else? What order is it? It's number of trials. Here, can I see it real quick?
Probability.
So binom. Exactly. Oh, yeah. Trials, probability. Okay, yeah. So trials, probability, and total number. Is that how I write it?
You wrote 4.
I just put a 4, huh?
Yeah.
I didn't get more specific than that. All right. So, yeah. So number of trials. So, oh, yeah, I see. And the number, this is just the number that you want. Yeah. So it's going to be the number of trials, 4, the probability each time, 0.66, and we want 4. Because we want 4 out of 4. So out of 4 trials, we want to get 4 successes. That last number is the number you want. They're saying get exactly 4 that have the health insurance. Exactly 4 successes. So that's going to come out pretty low. It's either A or C, I think. A. 0.190. Did you get that okay? Not making sense? Will you be able to recognize? It's always the trick, huh? Recognition. Spend some time practicing the recognition. Go over this thing and see if you'd recognize that. It's because it doesn't mention normally distributed anywhere. And it's a 2-state thing. All right. I'll move on. This will be on YouTube later. 28, number 20. A 28-year-old man pays $181 for a 1-year life insurance policy with coverage of $150,000. If the probability that he will live through the year is 0.9994, what is the expected value for the insurance policy? Round to the nearest dollar. So that's on the final exam notes, right? What does it say? Is gambling or insurance? Right? Number 6, is that what it is? There it is again. So in L1, you're supposed to put dollars win minus dollars cost to play, and then negative cost to play, and probability of winning, probability of losing. All right, let's do it. So getting back there. So in L1, we're supposed to put the dollars that you would win minus the dollars cost, and this one negative dollars cost, and then L2 will be the probabilities. Okay, so what's that going to be? How many dollars do you win? Well, we should put the two situations. How do you win in life insurance? You die. Your family wins, right? So that's what my dad used to always joke about that. Life insurance. You're betting you're going to die. That's right. That's exactly what it is, right? And if you live through the year, well, then financially you lose, right? It's a rough situation. You only win by dying. All right. So you win. How much do you win, or does your family win if you die during the year? What is this win amount? That's the $150,000. They get the $150,000 minus what you spent to buy the policy. $181, huh? So just put that in L1 as the first blank, and the second blank is just minus 181 because that's what's going to cost you financially if you live through the year. So we're just basically saying, look, if you die during the year, what's going to happen to your bank account? You'll gain 150, but you lost $181 by the policy. Whereas if you live through the year, you're just going to lose $181. That's why it's negative. And then L2 has the probabilities of those things. So what's the probability that you're going to die during the year? 1 minus 0.9994, right? If 9994 is the chance you're going to live, then 1 minus it is the chance you're going to die. So there's what you put into L1 and L2. And you can just type them in just like that. You don't need to figure them out first and then type them in. Just literally type those things into the boxes in L1 and L2. And then when you're done, you know what to do, right? Hit Stat, like usual. We're going to hit Stat, Calc, and when it says 1 var, you're going to do L1, L2, or if you have the old style calculator like I do, or if you have the ones that say list and frequency list, then that's when you put L1 and L2 that way. Hit enter. Is it minus $91?
Yes.
There's our answer. What does that number even mean, minus $91? On average, huh? That's how the insurance companies know what they're making. On average, they'll gain $91 per policy. Right? For most people, they'll make $181. They'll live through the year. But some people will die and they'll have to pay out. It'll all average out to where they're making about $91 a policy. That's how they know where to set their rates and all that kind of stuff. Question. So if the chance of rain tomorrow is 20%, what's the chance it won't rain? 80. And how do you get that? 1 minus, huh? So if the chance of living is 9994, the chance of not living, dying, is 1 minus that. That makes sense? Good. On to 21. A company purchases shipments of machine components and uses this acceptance sampling plan. Randomly select and test 30 components and accept the whole batch if there are fewer than 3 defectives. If a particular shipment of thousands of components actually has a 7% rate of defects, what is the probability that this whole shipment will be accepted? These were some of the harder questions from exam 2. So, how are we going to do this? What basic kind of question is this? It's a binom. Because there's 2 states, right? Either a product, a component is good or bad. 2-state situation. So it's some kind of binom. And also it never says normally distributed anywhere, does it? So it's not one of those bell curve things. It's a binom. Okay, and now what in particular are they asking me to do with the binom? If there are fewer than 3 defectives, what? They accept the whole batch. So they're asking me, they're saying, what's the probability that they're going to accept the whole batch? What's the probability they're going to accept the whole batch? Well, that's the same thing as asking the probability that there are less than 3 defectives, huh? That's what the words say right here. Fewer than 3 defectives. If there's fewer than 3 defectives, the whole batch is accepted. So if they're wanting to accept the batch, they're hoping there's going to be less than 3 defectives. So how do we figure that out? Is that a binom PDF or binom CDF?
CDF.
Binom CDF. And remember what you put there. What's going to go right? What goes in that first slot on the, if you look on the final, this is final exam notes, what, number 9? Is that what it is? 7. So number 7. So look on final exam notes number 7. So when you look there, what does it say goes in that first spot? Isn't it number or less?
No.
Let me double check.
Trials. Number of trials. CDF, number of trials, prob, and less of 3 or less.
At least 4, more than, at most 4, less than. Right. So number of trials probability 3 or less. Right. Thank you. So it's number of trials. That first spot, number of trials. So number of trials, probability, number or less. So how are we gonna do that? What's gonna go in this one? What's the number of trials? Yeah, we're selecting 30 components. Good job. So we're selecting 30 components. What's the probability each time? 0.07, right? 7% are defective. 7% rate of defective. 7%. So that whole batch of whatever it is, of stuff, 7% of them are bad. So every time we reach in there, we have a 7% chance of getting a bad one. We're going to reach in 30 times. And what we want to get what number or less defectives? If you're wanting less than 3, that's what number or less? 2 or less. Does everybody see that? That's 2 or less. Less than 3 means 2 or less, doesn't it? So that's what we put into our calculator. And what's the answer on that one? It's A? 649. Here it is. We covered a lot of stuff this semester, didn't we? Some tricky concepts. These are some of the hardest things, I think, in the course for this exam 2 stuff. Shall we move on? Questions on that one? Feel free to stop me. I know I'm moving quick. Feel free to stop me. 22. In a survey of college graduates, 56% reported that they entered a profession closely related to their college major. If 8 of those survey subjects are randomly selected, what is the probability that exactly 3 of them entered a profession closely related to their college major? So what's that one going to be? Is this another binom? Yeah. For sure, because you're either having a job related or not related to your major. So it's binom again. Now is it binom CDF or PDF? PDF, because it said exactly, huh? Exactly 3. And so how does it go? Number of trials, probability, and then the exact number. So what's the number of trials here? 8. 8 of those are randomly selected. What's the probability each time? 0.56. 8.56. And what exact number? We want 3. So there we go. And what's the answer on that one? C? 0.162? This all coming back? Like a sweet memory from the past? All right. On we go. We need 23 on the fresh screen. No, we need it here. All right. 23. Suppose that replacement times for washing machines are normally distributed. Did you catch that word? So is this a binom?
No.
No way. Normally distributed. So it's one of the, that's the buzzword, right? Normally, there's words you want to hone in on. There's a big one. Normally distributed. So we're going to go to, what is it, number 8 or
8?
8. So it is 8 on the final notes. With a mean of 8.4, standard of 2 years, find the replacement time that separates the top 18% from the bottom 82%. It will really help you to draw a bell curve. I know a lot of people struggle with that, but that's the key. If you draw the bell curve, I think you'll get the right answer. So let me help with the bell curve. So we're going to draw a bell curve. Draw a bell curve, and right in the middle, what's the average? 8.4. And a replacement time that separates the top 18%. Now, what do we mean by top 18%? Percentages always go above the curve, remember? So we mean like this is the top 18%. I want to find this time down there that separates the top 18% from the bottom 82%. You see, we're talking about areas within the curve, right? This bell curve holds all the washing machine replacement times. The average washing machine takes 8.4 years before it needs to be replaced. Washing machines that last longer, take longer time, and they're in the top. So the top 18% is somewhere up there. It's going to be above 8.4 years, isn't it? So I want to find that time. So as you go to the final notes number 8, you guys said, right? Final notes number 8. Now it distinguishes two kinds of questions there. I know it has 3 blanks, but really it's 2 kinds of questions. Either they're asking for a percentage or giving you a percentage. Did they give us a percentage on this one?
Yes.
Oh, for sure they did, right? They give us 2 percentages, 18% and 82. So this is one of those where they're giving us a percentage. Okay, so what do we do in that case? Inverse norm. Inverse norm. And how does inverse norm work? Area to the left, comma, mean standard? Yeah, mean standard, right? Mean standard. All right, so what is the area to the left?
82.
Yeah, remember, this is the spot we're talking about. This is what we're trying to figure out. Is right here, what is the line separating the top 18 and bottom 82? So what's the area to the left of that spot? 0.82. Yeah. What's the mean? 8.4. What's the standard? 2 years. Put it in your calculator. What is it?
10.2 years.
10.2. In other words, the top 18% of washing machines last 10.2 years or better. That's the line for the top 18% of washing machines. Good there. So that one takes some practice. Questions on that one? Right on we go. What numbers is it? 24? Okay, so 24. A bank's loan officer rates applicants for credit. The ratings are normally distributed. There's our key word, huh? It's another bell curve problem. Normally distributed. With a mean of 200, standard 50, applicant is randomly selected. Find the probability rating between 170 and 220. You could probably do this one without drawing a bell curve, but it might be helpful. Draw a bell curve. The middle, the mean is 200. They're asking me find the probability between 170 and 220. Are they asking me for a percentage or giving me a percentage on this one? They're asking. Yeah, they never gave me a percentage anywhere. did they? They're asking for a percentage. Again, this is final notes number 8. Is that what this is?
Yes.
Number 8. Asking for the percentage. That's normal CDF, right? Normal CDF. Left edge, right edge, mean, and standard. Left edge, right edge, mean, and standard. Okay, so the left edge is the 170. The right edge is the 220. The mean is the 200, and the standard is 50, they said. So there we go. Type it in. What's the answer on that one? C.381. Good? On we go to number 25. Suppose that replacement times for washing machines are normally distributed. Mean, this sounds very familiar. Mean 9.3, standard 1.1. Find the probability, a little different. Find the probability that 70 randomly selected washing machines will have a mean replacement time less than 9.1 years. So normally distributed again. So for sure, we need to draw ourselves, I'm going to draw it down here. We need to draw ourselves a bell curve on that one and put the middle on there. Let you try that one. All right, so the mean, what is the mean? 9.3. So the average washing machine in this problem lasts 9.3 years. And find the probability that 70 randomly selected washing machines will have a mean replacement time less than 9.1 years. Where's 9.1? Right here. Less than, so you put the other value on the normal curve, the 9.1, that's below 9.3, so it's left of the middle, isn't it? And then which way am I going to shade? Do they want the numbers higher than 9.1 to the right, or the numbers lower than 9.1 to the left? Less than 9.1, this way, huh? Does that make sense? See how the less than or greater than tells you which way to shade. So this is going to obviously be, well, are they asking me for a percentage or giving me a percentage? Did they ever give me a percentage anywhere? Yeah, no. So they're asking for a percentage, huh? So they're asking for a percentage. This is, again, final notes number 8. They're asking for a percentage. That means it is normal CDF, which is left edge, right edge, mean, and standard. Okay. Now, when we say left edge, right edge, all that business, what do we mean the left and right edge of? The shaded piece, huh? The shaded piece. So here is the shaded piece. So 9.1 is his right edge. That's his right edge. But what's his left edge? Yeah, remember it's like a number line. So this is negative, and I always just do 5 nines. That's the left edge. Yeah, it's like a number line. You know, negative numbers go left forever. Positive numbers go right forever. That's basically negative infinity for the calculator, we're saying, right? So remember, if the piece of shading goes left forever, that's negative with 5 nines. If it happened to go right, if they were wanting me to figure out a shaded piece on the right that went right forever, I would use positive 5 nines, wouldn't I? Yeah, so the left edge is minus 5 nines. The right edge is 9.1. The mean is 9.3. And the standard, what is the standard? 1.1. And that's not all. Look at those final exam notes. What else is there? Look at the underlined words. Look at the words about in. Remember, one of them says they're asking for a percentage and in is 1. And the other one says they're asking for a percentage and in is more than 1. See that? What's our in here? 70. That's our in. We're not talking about one washing machine having a time less than 9.1 years. We're talking about the average for 70 washing machines. So what do you do then when there's an in value greater than 1 according to the final exam notes? Divide the the standard deviation by the square root of 70. on the final exam notes. Are you going to be able to remember that along with everything else? Not unless you put some hours in. All right, and what's that? I bet it's going to come out soon. It's got to be D. I'm betting on D. No, A maybe. Is it D? E. So what's the answer? What's the number? 1 more time. What do you got?
064.
064. Is that what y'all are getting? 064. So yeah, that's none of the above, huh? Which is also disturbing. 064. So it's good to have an answer on YouTube so you can check yourself. 064. Is that good? So remember that divide by the standard deviation. On we go to number 26. In a batch of 8,000 clock radios, 2% are defective. A sample of 11 clock radios is randomly selected without replacement from the 8,000 and tested. The entire batch will be rejected if at least one of those tested is defective. What is the probability that the entire batch will be rejected? Let me let you look on the notes. You could do it as a binom, because it is a binom. That'd be fine. But also, I think I specifically put on there somewhere at least one. Didn't I? Maybe I didn't. Did I?
Yes.
What number is that?
Number 7.
Number 7. So final notes. Number 7. So we go. Well, 7's not in my copy. So, all right. So what do I say for that? Don't I say at least one? At least one is 1 minus naught times naught times naught, etc. Right? Is that what I did on that? Is that what I wrote there in your final notes? We don't have it?
It
There
just
seems.
says at least 4. It doesn't say.
All right, so forget that plan. I mean, that's a good way, but we'll do the binom thing. So it's binom, and we have an at least one on the binom. So it's binom. Let me put it up here. Binom. And how's the binom go? Oh, is it binom CDF or PDF? CDF. And number of trials, probability, and then number or less. So number of trials, probability, number or less. So they're saying that we want to have at least one of those defective. At least one defective. At least one. Okay. So what's the number of trials?
8,000.
Yeah, it's 11, isn't it? I don't see the 11. Oh, yeah, there it is. Yeah, we're pulling 11 out of the 8. We're not pulling all 8,000. We're not looking at all 8,000. We're only looking at 11. We're pulling 11 out of the group and examining them. Right? And if just at least one or more, is bad, we're rejecting the whole sample, the whole shipment. What's the probability each time that we're going to get a bad one? 0.02, right? 2% are defective. 2% sample of 11, 2% are defective. Each time, so there's 8,000 of these things, and each time you reach into the batch, there's a 2% chance you're going to get a bad one because 2% of them are bad. You're going to pull out 11, and what's the number or less you're looking for?
0.
Yeah, you see, the problem is we're not really doing a number or less. We're doing at least one, which means one or more, doesn't it? At least one means one or more. So that's the opposite of 0 or less. So you've got to do the binom, CDF, and then take 1 minus the answer, don't you? Does everybody see why that is? Because 1 or more is the opposite of 0, isn't it? Does that make sense? Getting 1 or more bad ones, the opposite of that is getting no bad ones. So we figure out the chance of getting no bad ones, right? 0 bad ones, and then take the opposite of that. And that'll be the chance of getting 1 or more bad ones. What's the answer on that one?
B.
D? B as in boy? 0.199.
So what's the difference between the...
It's at least 4. So at least 4. You do the binom, CDF, and what's the back number? 3, right? Are you tracking with me? Looking at the at least 4 example in the final notes, what I just did is exactly consistent with that. What do you do with at least 4? You lower it by 1 and then do 1 minus the answer. That's what I did with at least 1. I lowered it by 1 to 0 and did the opposite. That's the same thing. Glad to talk with you about it later. Let's move on. 27. The table below describes the smoking habits of a group of asthma sufferers. So there we go. If one of the 981 subjects is randomly selected, find the probability that the person chosen is a non-smoker given that it is a woman. Non-smoker given that it is a woman. So the probability non-smoker given that it is a woman. What do we do with given? Do you remember the given statements? Remember how given narrows the field? Remember I did examples where I said, hey, I'm rolling a die. What's the chance I'm going to get a 6? And you'd all think, well, 1 in 6. Right. But then what if I said, hey, I'm going to give you some information. I got a number higher than 4. So then if you're given that information, that limits the denominator, doesn't it? If you know I got a number higher than 4, well, then there's only 2 possibilities. They've got a 5 or a 6. So there's only 2 in the denominator now. Makes sense? Given, when you're given information, that limits the possibilities. Remember we talked about Martha Stewart and going to prison for insider trading. That's exactly why insider trading is illegal. Because if you know something about what the company's doing, it's not so random for you. Right? You have an unfair advantage. So given information changes probabilities. So whenever you have a probability with a given, the bottom is the given. Instead of total, not total, but given goes in the denominator. Because normally, for probability, the bottom is always total, isn't it? But for a given question, the bottom becomes the given amount. All right, so what are the numbers on this one? 981 times. We're given that it's a woman. How many women are here?
464.
Did you add those up? Okay. So if you add up all the women here. Oh, no, the total's there. Yeah, I'm not even looking. There we go. I better put in there. There's the totals. Yeah, 464 women total. It just says it right there. There's 464 total women. So that's going to be the denominator, right? It's out of one of those 464 women. We're given that it was a woman. So it had to be one of those 464 women. What's the chance it was a non-smoker? Yeah, because 312 of those women are non-smokers. 312. So divide that on your calculator. And what's the answer there? It's got to be or maybe it's not there. It's not there. 312 divided by 464. I'm getting 672. 0.672. None of these. There it is, your favorite answer. We good there? Does that make sense? So, given. So if you need to add that to your final exam notes, feel free to do so. Given limits the denominator, doesn't it? It becomes the denominator. Number 28. A survey of adults from one town shows that 61 have health insurance, 31 do not. Find a 90% confidence. Here we go. Here's the stuff we're used to. We're finally out of the second exam now. All that probability stuff. Find a confidence interval for the true proportion of all adults in the town who have health insurance. So we know how to do this. Will be easier now, I think. It'll be much fresher in your mind. Can you do that one? All right. So which one is this one going to be? These are proportions, huh? So it's going to be, but it's just one proportion, isn't it? One proportion. So we go to stat, test, one proportion, Z, what? Interval, because it's a confidence interval, huh? One proportion, Z interval. And it asks you for X, for N and for the C level. Confidence level is 90%. X, what is X in this one? Is it the 61 or the 31?
61.
How do you know?
61 have.
Good. See what it's asking? Who have health insurance. That's 61. Well, then what's the N?
92.
Got to add those together. Remember, N is always the total, and you got to add those together. That's right. 61 and 31 add up to be 92.
I would totally let that slip that you know I asked it that way. I knew there was a truth behind it.
There it is. So put that in, hit the C level. So 61, 92.9, and calculate. And it is C, 0.582 to 744. Is that good? Questions on that one? You're good there? So, all right.